Is my screen visible to everyone?
Yes, sir.
Okay. Thank you. And my voice is clear, right? There is no lag in voice. And please kindly mute your mic also. So let's start today's lecture. Please mute your mic. So as we have complete left our lecture, tomorrow with at the end mesomeric effect and inductive effect. So there are some more question you guys want to solve. So today's lecture we will start up with the some practice questions of mesomeric effect and inductive effect. And please mute your mic. Mesomeric effect and inductive effect. And then we will move towards the important naming reaction and many questions on the naming reaction which has been asked in recent year GPAT question papers. So that we will solve. So let's start today's session with this MCQ. Following group exert any one of this effect on electrophilic aromatic substitution. Identify whether they all are. So try to read this question and first uh, type your answer in chat box. First group is OC2H5, second group is NHCOCH3, and third group is OCH3. What would be the answer of this question? Type your answers in chat box. 1. No. Try to recall the order I have told. Try to recall the order. Activating groups, you are near to, but all questions have all options except one having activating groups. 3 options having activating. Which one? Strong, moderate, or weak? Okay. So moderate, yes. Naga Ishwarya. Why moderate? Why? Why moderate? Can you tell me the reason? The reason is hidden in that order itself. My voice is not audible. Is it problem with everyone that my voice is not clear? Everyone have the same problem? Okay, Naga Pranvi, I think there is a issue from your side. My internet connection is normal. So why moderately activating? Because if you see that order, so the starting groups, as I have told, that in starting group, the order of plus M group, the starting groups like NH minus, then O minus, then NHR, then NHR, NHR3, then NHR. Please mute your mic, please. NHR, then NH2. So this all starting groups are known as strong activating. Okay. So they all are strong activating groups. according to that order. Okay. So these groups NH minus, then O minus, then NH, NH2, then NHR, then NH, NR3, or you can say NR2. Okay, and then this all group, this OC2H5, then this NHCOCH3. If you have observed these all groups in this question, they are in the or you can say middle of the order. In the order, they all are in between. So that's why the answer of this question will be moderately activating. Okay. And the strong activating, if they ask, then these groups are strong activating. This all. Okay. So these groups are strongly activating. And all in the last, like chlorine, fluorine, they all are, you can say, comes under the weak activating. Remember, I also told that chlorine also have I minus effect and plus M effect simultaneously. The halogens, chlorine, fluorine, bromine, iodine. So they all comes under this category. Okay, and this all groups in the question, they comes under the moderately activating and strong activating. These groups are strong activating. Okay, clear to everyone? Is it clear to everyone? Okay. Now we'll start with some naming reactions. Just a minute. Is my screen visible to everyone? Okay, okay. Okay. So can you identify this first reaction? Whatever the reactions I'm going to cover, this all reaction already has been asked in previous year questions. Is it anyone? This is revision for you guys. So I'm expecting the answer from your side. Bayer, Beckman, yes. Naga Ishwarya, Beckman rearrangement, yes. So this is Beckman rearrangement. What happens in case of Beckman rearrangement? There is simply a carbonyl compound will react with this carbonyl compound will react with the hydroxylamine and then it forms a oxime. What it forms? Oxime. This group is known as oxime. Okay. So when it starting material is ketone in here in case. So this intermediate known as ketoxime. Okay. So intermediate will be known as ketoxime and then again it undergoes the removal of water. Okay, and end product will form a substituted amide. This group is amide, right? And what is this compound name is? The name of this compound? They have asked that via which reaction we can form a caprolactam. So this is caprolactam, okay? So Bachmann rearrangement, through Bachmann rearrangement, we can form a caprolactam. Okay, this is a structure of caprolactam. Okay, and it's a amide compound, cyclic amide compound. We can also form a aliphatic also, which means linear compound. We'll see some example. There is a MCQ on this also. Many times from Bachmann rearrangement, they have asked the question. So this is the simple reaction. With the carbonyl compound will react with the hydroxylamine. This is known as hydroxylamine, and it will form a oxime. If it is ketone, then it will be ketoxime. If it is aldehyde, then it is known as aldoxime. And then uh, it again undergo one more step, which is in presence of acid. There will be a concentrated acid. Okay, it may be H2SO4 or HCl, under which it undergoes the removal of water, and then it forms the substituted amide. Okay, and then it forms the substituted amide. So this is Bachmann rearrangement. And one more question they are used to ask. We'll discuss it in the end. Okay, that on which rearrangement this substitution of the group take place on the nitrogen. There is a one naming reaction we are going to study, that is where the substitution of group after rearrangement take place on the oxygen. Okay, so that kind of questions are also has been asked in previous year GPAT question papers. Anyone able to identify which reaction is this one? If you are able to find identify this group, what is the name of this group? Anyone? Which reaction is this one? Try to answer fast. This is very important. Naming reaction part is very important topic, because there are many questions. Many questions. In NIPER, you are almost able to find 7 to 8 questions from the naming reaction, and in GPAT also 4 to 5 questions directly and indirectly. They will ask 4 to 5 questions, which means almost 15 to 20 marks. So a very important portion of organic chemistry is naming reactions. Yes, Smith rearrangement. Karthikeyan. When I was moving the slide, may some of you guys have may noticed the name of the reaction. No problem. Okay, Smith rearrangement, right? So it's a Smith rearrangement, right? Yes, it's a Smith rearrangement. Okay. So what happens in case of Smith rearrangement? Here also, if you see the group, R group, this R group is transferred on the nitrogen. So remember one more reaction where the rearrangement, after rearrangement, the alkyl or a aromatic group is transferred onto the nitrogen. The first one was Bachmann. The second one was second one is Smith rearrangement. There will be one or two more examples where the rearrangement of the group is taking place on the nitrogen. So what happens in case of the Smith rearrangement? We are using a ketone or carboxylic acid. Okay, this is carboxylic acid and this is ketone. I have written as C and K. Okay, K for ketone and C for the carboxylic acid. So this carboxylic acid will react with the, what is the name of this compound? What, or we can say what I can tell this group as, what is the name of this group? Three nitrogens. Yes, azide. Very good. Very good. Yes, it's a azide group, right? So when you react your carboxylic acid or ketone with the azide group in presence of acid, this H plus representing the acid. Acid may be HCl or H2SO4. Okay. When it react with the azide in presence of acid, it will give me a first degree amine. Remember, first degree amine only. Okay. Only first degree amine. They may try to trick you. They may give also gives you an option of 2-degree amine, 3-degree amine. Okay. So there will be a chances, but remember, only and only first degree amine can form with the help of Smith rearrangement. Okay. Simply ketone or a carboxylic acid react with the azide in presence of strong acid, and it will gives me a first degree amine. Okay, primary amine. So this is the simple reaction. We are not going in the mechanism because otherwise the lecture will be too much longer. And as it is revision, and you guys also have to remember the reaction itself only. Mechanism in short you can remember, short type, but do not try to remember the mechanisms. In some cases it is important that at that time I will tell you, in case of Backman and all, when we solve the MCQs. Okay, so this is the Smith rearrangement. What is this reaction? This reaction, which one? Which one is this reaction? Which one is this reaction? Acyl azide is a starting material. If try to recall. Acyl azide. See, again one reaction where the rearrangement of the group is taking place on the nitrogen. So remember one more. I have compiled all starting so you can get idea that Beckman, Smith, and this reaction. In all reaction, the rearrangement of the group is taking place on the nitrogen. Courteous. Very good, Manisha. Very good. Very good. Yes, it's a courteous. So this reaction all are very similar type of. Okay. Here what we are going to use is aldehyde or ketone. Okay. They will react with the azide, and then, or we can use a, you can say acyl chloride. Okay. Acyl chloride or alkyl chloride. Okay. Sorry, alkenyl chloride, that is RCOCl. Alkenoyl chloride. Okay. RCOCl ketone or aldehyde. They will react with the azide, and then it will, they form the acyl azide. Okay. This RCO group. If I use CH3 here in play as a R group, then it is known as acyl azide. Okay. When this acyl azide react, or we can say heated, first it will formed through reaction with the azide, and then it will form the acyl azide. And when this acyl azide heated, so it will convert it into the isocyanate. This is known as NCO group. This NCO group known as isocyanate group. Okay, NCO. That group is known as isocyanate group. Okay. And now here the three possibilities can be, or you can say this isocyanate intermediate can undergo different three reactions. In presence of alcohol, when you react it with the alcohol, it will form a carbamate. This is also important. Okay, because this can also be asked to you from a specific part, that isocyanate, then they will give you alcohol, that isocyanate is reacting with the alcohol, what would be the product. And as a R group, they can give you here a CH3 or a C2H5, or any group. They can just you can say place the group, and they will give you the reaction, and they will ask you for the product, if for example in presence of the alcohol, or just simply reaction with the water, then it will gives you amine. And if you react it with the amine itself, then it will gives you a urea derivative. If you have observed, here is a NHCONH, which is urea. Okay, this part is of urea. Okay, so this is Curtius reaction. Again, in this reaction, the rearrangement of the group, R group, that is alkyl group, is taking place on the nitrogen, same as Bachmann and Smith rearrangement. Okay, so remember this one also. All reaction, naming reaction, I'm going to cover. From that, questions, lots of questions has been already asked. So this all are important naming reaction. Any simple naming reaction I am not taking. Okay, all are very important, very. Okay, so try to remember it as I am going through. Okay, any question in this? Anyone? This is the Curtius reaction. And also note down the difference between them, because you may get confused between Smith and Curtius. Because in case of Curtius, we are using a carboxylic acid mainly. We can use ketone also, but mainly the carboxylic acid is used. And that carboxylic acid is reacted with the azide in presence of acid. Here we are only using a heat. And here we are using a acyl azide. Okay. So this is Curtius reaction. Okay. Now, which reaction is this one? Anyone? Hoffman what? You are correct, Manisha, but Hoffman, then what is the full name? Hoffman, it can be elimination. Hoffman, it can be anything. Hoffman bromamide. One more word is there, Hoffman bromamide. Yes. Hoffman bromamide degradation, yes. So it's a Hoffman bromamide degradation, or you can say Hoffman bromamide rearrangement also. Yes, DI, you are right. Okay. So we can tell it as a Hoffman bromamide degradation or Hoffman rearrangement also. So here, if you see what happens in case of Hoffman bromamide degradation, that as a starting material, we will use amide. It can be aromatic or aliphatic. Okay, again I am repeating, aromatic or aliphatic, both can be possible. Aromatic or aliphatic. Okay, aromatic or aliphatic, both can be possible. Here they have used benzamide. Okay, on benzene there is a CONH2 group, so it is known as benzamide. Now, simply what you have to remember, when a amide undergo Hoffman bromamide degradation, it will form a product with the one less carbon. Like here, it is one carbon only. Okay, so it will form a aniline. Obviously, this NH2 group will attach here on this place. Okay, and it will form a aniline. For example, if I use CH3, CH2, CONH2, what will be the product form for this? I have just told you the concept that the product will be formed with the one less carbon. When amide undergoes Hoffman bromamide degradation, ethylamine. Yes. It will forms a ethylamine. Yes. Okay. So you just have to remove this CO group. Okay. And how it will get removed? So this reaction is carried out in presence of bromine and NaOH, in presence of base NaOH. So this bromine will react here. Also one thing that they have written KBr and K2CO3. Here in actual you can use both KOH and NaOH. Okay, so they have considered KOH here. If the NaOH is there, there will be Na2CO3. NaBr. Okay, so both can be used, KOH or NaOH, both can be used. Okay, so any one they will gives you. So here, when it react in presence of KOH or NaOH with in presence of bromine and NaOH or KOH, okay, so it will form a amine with one less carbon. Okay, and also it removes the K2CO3, KBr, and water. So how you can balance also? So you can think it in a way. Here see, as here two bromines, so this require will be 2 moles, right? Okay, or you can say 3 moles. So 3 moles of KOH. So 2 will react with this you can say CO group. Okay, so that CO2 and that 2K minus, they will form a K2CO3. Okay, and this and KOH, this KOH, one more you can say potassium is remaining to have reacted with the CO3 minus 2 group and form the K2CO3, and then is one more potassium is remaining, so it will form a KBr. Okay, so this is how the reaction is balanced. So here 3 KOH and 1 bromine is required. Okay, so simply you have to remember that amide, when undergo Hofmann bromamide degradation in presence of KOH or NaOH with bromine, it will form a amine with the one less carbon. Okay, clear to everyone? If you are not getting anything, you can ask in chat box. Okay. So it's a Hofmann bromamide degradation reaction. Sorry, so the name already comes. So it's a Robinson annulation reaction. Okay, you guys are lucky that you does not have to give the answer of this question. Okay, so what happens in case of Robinson annulation? There is a alpha beta unsaturated carbonyl compound. Unsaturated, okay. When this alpha beta unsaturated carbonyl compound reacts with a saturated, I am again repeating, saturated, and mostly in most cases it will be cyclohexane. Take this compound as a kind of a moiety, main moiety. Okay, so it will be react with the cyclohexane, hexanon, okay, as a saturated carbonyl compound with the alpha beta unsaturated carbonyl compound in presence of base. So what will happen, that if you see, these are 4 carbons, right? If you calculate, so these 4 carbons will attach to this ring here, attach to this ring here. If you see this one, okay, these 4 carbons will attach, sorry, not that side, this side. Okay, this side. So they will attach to this side, or simply these 4 carbons will attach to this side and it will form a ring. Okay, and that's why it's known as annulation. So what you have to simply remember, when you see a alpha beta unsaturated carbonyl compound is reacting with a cyclohexanon. Okay, cyclohexanon you can take as a reference compound for the Robinson annulation. Okay. So when it react with the cyclohexanon, it will form a ring, additional ring beside this hexane ring. Okay. This one is hexane ring. Beside this hexane ring, one more extra ring is get formed. Okay, so this is known as Robinson annulation. And one more thing you have to remember, that Robinson annulation is a combination of Michael addition and aldol condensation. I'm not explaining the mechanism in depth because it will may take so much time. So, in simple, remember that this Robinson annulation is a combination of Michael addition and aldol condensation. These two all reactions also we are going to study in upcoming slides. So, this first, what happens in Robinson annulation? First, the Michael addition take place. Okay, and because of Michael addition, this entire aliphatic chain, or this linear chain of this 4 carbon, okay, this 4 carbon carbonyl compound, unsaturated carbonyl compound, will attach to this carbon here. Okay, here it will attach to this carbon because of the Michael addition, and then because of the aldol condensation it will undergo the annulation. It means ring closing. Okay, it will undergo the ring closing. So ring will get closed, and because of that you are able to see here a ring in final product. Okay, so first step is the Michael addition, and then second step is the aldol condensation. Okay, Michael addition is taking place in the alpha beta unsaturated carbonyl compound also. Okay, you are able to get it? Anyone, any question in this Robinson annulation? What you have to remember is cyclohexanon is reacting with the alpha beta unsaturated carbonyl compound, and then it will gives a one additional ring attached to our final compound. One additional ring will be attached. Okay, annulation, it means ring formation, and that ring formation is due to the Michael addition and aldol condensation. First step is Michael addition, and then second step is aldol condensation. This also can be asked as a question, that what is Robinson annulation is a combination of which two reactions. So you have to answer accordingly. Michael addition, aldol, and they will give you then Michael addition, aldol condensation, Michael addition, then Smith rearrangement, and all the combination possible. Okay, so this kind of MCQs can be asked. Anyone, any question? If you are not able to get anything in this reaction, okay, at this time the it's not possible to explain reaction mechanism because it may take so much time. So as a part of revision, we are just trying to go through the reaction. Okay, and as much as possible through in the reaction itself, I'm trying to explain some part of mechanism. Okay. Okay, so we will move to the next reaction. Which reaction is this one? Toluene is forming the benzaldehyde as a final product. Which reaction is this one? This all are from the previous year GPAT question papers. Okay. And previous also the recent year 2022, 2023, and 2021. ITAD. Yes, yes, ITAD. Only Manisha is answering the naming reaction questions. All have to answer. Okay. Because everyone have to do the revisions. So it's a ITAD reaction. So in case of ITAD reaction, what happens that the toluene will react or converted into the benzaldehyde in presence of chromyl chloride. This compound is known as chromyl chloride. This one, chromyl chloride. Chromium is there, right? So it's known as chromyl, or you can say chromyl chloride. chromyl chloride. Okay. In presence of chromyl chloride and carbon tetrachloride, it will directly remember the final product, which is benzaldehyde. Okay. So what happens in ITAD reaction? Toluene will converted into the benzaldehyde in presence of chromyl chloride and CCl4. They are also used to ask the reagents. Okay. Sometimes directly they will ask you which of the following reagent will be used in the ITAD reaction, or they will give you the reaction and they will just question mark here. What will be the reagent? So you also have to recall that this is ITAD reaction because it's converting toluene to benzaldehyde. Okay. So we have to select the and also you have to look into the options because there may be other organic reaction possible that benzyl toluene is converting into the benzaldehyde. So you also have to look for the options that whether the chromyl chloride and CCl4 is there in the option. If that is in the option, definitely it's a ITAD reaction they are asking about. Okay. So in ITAD reaction, toluene is converted into the benzaldehyde in presence of chromyl chloride and carbon tetrachloride, that is CCl4. Okay. You guys will get idea that how important these reactions are as when we start the MCQ solving. Okay. That how many number of MCQs has been asked from this reaction itself. Which reaction is this one? Which reaction is this one? I want fast answers. Okay. So we can cover more number of MCQs. Do you have idea? Anyone? What is this reaction? There is a salt, or you can say carboxylic acid salt of carboxylic acid salt of silver chloride or silver salt of carboxylic acid. What is this reaction? Okay, it's a Hunts-Daker reaction. Okay, it's a Hunts-Daker reaction. This was, I think, from a few years ago. This was asked in GPAT and also as well as in the NIPER 2020 or 2021. They have asked this question regarding the Hunts-Daker reaction. One time in GPAT and one time in NIPER, this question has been asked. So this is Hunts-Daker reaction. What is important is the silver salt of carboxylic acid. Also remember the starting materials. They also give you the name of starting material and they will ask you the name of reaction. So try to go through every possibility. Okay. Try to go through every possibility of the reaction. That what kind of MCQ, as I mentioned yesterday also, they try to see every possibility in a one MCQ or in a one MCQ, that what kind of other variations can be possible. Okay, so here the silver salt of carboxylic acid will react with only CCl4 in presence of a halogen. It can be Cl2, it can be bromine. Okay, these two mostly. So in presence of CCl4 and also in presence of chlorine or bromine, it will gives me a alkyl halide. Okay. And also CO2 gets removed and it will form also a silver chloride or silver bromide. Okay. As accordingly, if you use chlorine, then it will be AgCl. If it is bromine, then it will be AgBr. Okay. Simply, if you see, this CO2 is get removed. Okay. And this Ag plus will react with the one chlorine or bromine here, and one chlorine and bromine will attach to this alkyl group. Okay. So this is how the entire reaction you can remember. Okay. Silver salt of carboxylic acid react with the chlorine or bromine in presence of CCl4. Okay, and it will gives me alkyl halide, that is Hans-Decker reaction. Every reaction I am covering, they all has been asked in previous year GPAT or NIPER question papers. Okay, any question in this reaction? If you are not getting any reaction, type in chat box. Okay. Now, which reaction is this one? Which reaction is this one? I think you guys are weak in the naming reaction part. Try to answer fast. Or if you are getting some problem, just after completion of this lecture, go through the entire lecture. You will find almost every important naming reaction. Okay, and also we'll solve some MCQs at the end. Anyone have any idea? Anyone? Okay. I think nobody have any idea. This is Bamford Steven. Okay. What you have to, again, I am repeating, you have to see the starting material and the reagent. Based on that, you are able to get the idea that which reaction it is. Okay. So in case of Bamford Steven, what you have to observe is this one. Paratoluene benzene sulfonyl, which is attached with this imine. Okay, this is, you can told as a imine. This is because C double bond NH. Okay, so when this paratoluene, why I'm saying paratoluene, because this is a toluene. Okay, so paratoluene benzyl sulfonyl, and it is attached with the imine group. So this entire structure, when it react with the NaOMe, that is sodium methoxide. Okay, and this is strong base. This is act as a base. Okay, Lewis base. So in presence of that, this entire structure paratoluene benzene sulfonyl with imine group will converted into the alkene. Okay. Okay, it's a alkene. Okay, so simply you have to remember that whenever paratoluene benzene sulfonyl is attached with the imine group, okay, and when it react in presence of a strong base like sodium methoxide, there can be NaOC2H5, okay, or NaNH2. This all are strong base. This is sodamide, NaNH2. Okay, so it will gives me alkene, and this benzene sulfonyl group, paratoluene benzyl sulfonyl group, will get removed from that imine group. This entire group you can call it as a imine. This is just a substituted. Okay, so it will gives me alkene. So what will be formed in Bamford Steven is alkene from the paratoluene benzene sulfonyl substituted with the imine, and that paratoluene benzene sulfonyl you will get at the end of reaction here, and the alkene will get separated from it, and this two nitrogens, these two nitrogens will get removed in the form of N2 gas. Okay, nitrogen gas. Okay, anyone, any question in this reaction? Paratoluene benzene sulfonyl group substituted with the imine, in when it get react in presence of strong base, it will gives me alkene, and also the nitrogen gases get removed and the para-toluene benzene sulfonyl will get at the end of reaction intact itself. Okay, so what you have to remember is that formation of alkene from this starting material in presence of base. Okay, and the name of starting material I have already told. Para-toluene benzene sulfonyl substituted with the imine. Okay. Any question if you have, type in chat box. Now one reaction comes. What I am talking about, that in previous reaction, Beckmann, Smith, then Curtius, then Hoffman bromamide, what we have seen is that the rearrangement of the alkyl group is taking place on the nitrogen. Now here see, here if you see this rearrangement of this R dash group is taking place on the oxygen, here is the in the end product. Okay, and this is the question from GPAT 2022. This is the question from GPAT 2022. The same reaction, I mean, they have asked that in name of the reaction, that in which of the following reaction, we'll see that MCQ also, in which of the following reaction the rearrangement of the group take place on the oxygen. Which reaction is this one? Ketone is reacting with the per acid. Okay, this is ketone. And this is per acid. Beckmann, no. Beckmann में तो बेटा it is on the nitrogen, right? Here it is on the oxygen. The rearrangement of this R dash group is taking place on the oxygen. Clemention, no beta, it's a reduction reaction. Clemention is not a rearrangement reaction. In Clemention, it's a reduction. Yes, Bayer-Villiger, Manisha, very good. It's a Bayer-Villiger reaction, right? So what happens in case of Bayer-Villiger reaction? When a ketone react with the per acid. Why per acid? If you see a carboxylic acid, it is a COOH. Okay, so it's a carboxylic acid. And when, if you see a group like this, so here one extra oxygen is there. And that's why we tell it as a per acid. Okay. So that's why we tell it as a per acid. So when this ketone react with the per acid, it will forms a substituted ester. This is ester group, right? This group. So this is substituted ester. It will form a substituted ester. So the rearrangement of the group is taking place on the oxygen here. See, this R dash group in starting material in ketone, it is shifted on the oxygen. Okay, and here also somewhat the mechanism is also drawn, but I'm not going into that. I'm telling you the brief about the reaction, that ketone will react with the per acid. Okay, and in presence of acid also, here if you can write H plus. H plus means that particular reaction is carried out under the strong acidic condition, which means that that's why it's written H plus there. It will be H2SO4 or HCl. Okay, so in presence of acid, it will undergo the rearrangement reaction, and after rearrangement, that alkyl group is shifted on the oxygen, and it will form a ester. Okay, so that is what Bayer-Villiger reaction is. So it's a Bayer-Villiger reaction, right? So which reaction is this one? I think name maybe name was visible, but which reaction is this one? This is also the question from there is one more from this one. The question was asked in GPAT 2022. Which reaction is this one? I think you guys may have read the name, but just by mistake I have clicked, so the name was visible to everyone. Just few minutes, just few seconds ago, the name was visible to everyone. Which reaction is this one? Stork-enamine reaction. Yes, it's a Stork-enamine reaction. Say, Stork-enamine reaction. So what happens in Stork-enamine reaction? That the ketone or a aldehyde. Okay, generally here also as a ketone, in general cases, the cyclohexane is used. So whenever you find about the Stork reaction, the general reaction will be starting material will be cyclohexanone. Okay. One more reaction previously we have seen, in which reaction the cyclohexanone was used. Just a few slides ago we have studied about. Type the name in chat box. Okay, so this starting material ketone or aldehyde or in general the cyclohexanone. No, not Beckman. Robinson annulation. Yes, Robinson annulation is correct. So this cyclohexanone react with the alpha chloroketone. This is known as alpha alpha chloroketone. Okay, or alpha haloketone you can say. Alpha chloroketone or alpha haloketone. When this cyclohexanone or carbonyl compound react with the alpha haloketone, or alpha here is a chlorine, so alpha chloroketone. Okay, so it will forms this final material. What this one represents, this is the intermediate. Okay, that how if you see the first step. So in first step, it will react with this pyrrolidine. Okay, this heterocyclic ring is pyrrolidine. In which amino acid the pyrrolidine ring is present? In which amino acid? It's touching in the biochemistry also. Yes, proline. Yes, proline. Very good, Manisha. Okay, so this pyrrolidine in first step, it will react with the cyclohexanone and it will form enamine. Okay, as an intermediate, and that enamine will converted into this by you can say the 1,3 dicarbonyl compound. Okay, in the final product 1,3 dicarbonyl compound. So first this cyclohexanone will react with pyrrolidine and then it will give enamine, and this enamine will react with your alpha chloroketone and it will gives you a final material 1,3 dicarbonyl compound. Simply this group, just a minute. Simply this group which I am rounding here. This group, simply you have to attach here. See. Okay. But it is first, it will form the enamine and then that enamine will react with this alpha chloroketone or alpha haloketone and then it will gives you a 1,3 dicarbonyl compound. Okay. So this is Stork enamine reaction. Now we'll see in MCQ that how they have asked the question from this reaction. Okay. So you will get more idea. So simply what you have to remember, it will form a enamine intermediate. And that enamine intermediate is converted into the 1,3 dicarbonyl compound. Okay. After reaction with the alpha chloroketone. And starting material is a carbonyl compound and in general is a cyclohexanone. Okay. If anyone have any question in this reaction, you can ask. But this all reactions are very important because many questions come from these reactions. Now, which reactions are this one? Name written here. Which reactions are this one? Name is written here. That is, but you have to decide whether it's open year oxidation or MPV reduction. Which one? Open year oxidation. But it is also written MPV reduction. What is the difference between both of them? Both are written on this reaction, and they are reversible. Yes, very good, Manisha. Yes, very good. They both are reversible reactions. That is what I want, right? And one more question, okay, for you guys. In which drug synthesis it is used in the asthma? Okay, it is used in the asthma. The name of the drug is used in the asthma, and in the synthesis of that drug, the MPV reduction is used. Can you name that drug? This kind of question can also be claimed because MPV reduction is applied there. Very good, Mohammad Fatima. Very good, beta. Very good. Absolutely right. Salbutamol. Yes, in case of salbutamol, MPV reduction taking place. The same reaction will take place. Okay, in case of salbutamol, this MPV reduction will take place. In the synthesis of salbutamol, if you see properly, there is a written MPV reduction because it's also contain a ketonic group in starting material, and then when it converted into the final product, it will contain a OH. Okay, so it will because of the MPV reduction. Now let's come to the original topic. So here, in case of open year oxidation, what happens that this alcohol, 2-degree alcohol, specifically talking about 2-degree alcohol, when this 2-degree alcohol react with the excess keton in presence of aluminum isopropoxide, or also in case of open year oxidation, aluminum tertiary butoxide. Okay, in case of open year oxidation, generally they are using aluminum tertiary butoxide. If that is not in option, aluminum isopropoxide can also be used when this 2-degree alcohol with excess keton in presence of aluminum tertiary butoxide or aluminum isopropoxide, it will undergo oxidation reaction, and that 2-degree alcohol is converted into the ketone. And if you know, in general, when 2-degree alcohol is get oxidized, it will convert into the ketone. Okay, 2-degree alcohol, when it get oxidized, is convert into the ketone. So what is important is the excess ketone. You are reacting with the excess ketone, it is forming, but this ketone will be different. Here you are using excess as a acetone. Okay, starting material in starting material, the acetone will be fixed. In starting material, the acetone will be fixed. Okay, and that acetone, excess acetone, is reacting with the 2-degree alcohol. Okay, and in presence of aluminum tertiary butoxide or isopropoxide, and it will go on and undergo oxidation reaction, and it will form this different ketone. See here, it is R and R dash written, not the acetone itself. So this formed ketone will be different. Okay, and here this acetone is get converted into the isopropyl alcohol, that is 2-propanol. Okay, so simply this our starting material, 2-degree alcohol, is get converted into the ketone, and that acetone is get converted into the isopropyl alcohol. Okay, so one is get reduced and one is get oxidized. Obviously then the reaction can get completed, but why we are telling it as oxidation? Because our starting material, which is 2-degree alcohol, is getting oxidized. And when reverse of this, as I think someone has told that these are reverse reactions. Okay. So when you use excess isopropyl alcohol with the ketone, when you use excess isopropyl alcohol and you use aluminum isopropoxide. In previous one, what I have told in general is aluminum tertiary butoxide for open air oxidation. Here we use aluminum isopropoxide. Okay. And that will again go reverse reaction and it will form a 2-degree alcohol from the ketone. Okay. And that's why these are the reverse reaction, open air oxidation and MPV reduction. Okay. And MPV reduction, as I have asked you, in the synthesis of salbutamol, this MPV reduction is used. Okay. Anyone, any question in this one, in this reactions? Very important. All are very important. Every reaction is very important. You are able to get 4 to 5 questions or maybe more from the naming reaction itself, directly or indirectly. Okay. So these are open air oxidation and also the MPV reduction both. So here what I was explaining to you guys. See here. See here. If I use excess ketone, as I have told, then it will form undergoes the oxidation. See here. Okay. And then when I use excess isopropyl alcohol, then it will goes the MPV reduction, undergo MPV reduction. And here in open air oxidation, generally they use aluminum tertiary butoxide. Okay. Okay. Now, which reaction is this one? This is very simple one, and I think I am not able to remember the number of time that this was asked in GPAT and NIPER. How many number of time? Many number of time they have asked this reaction. Many number of time. And just frequently in GPAT 2023 also there was a one question from this reaction itself. Which reaction is this? Phenol is getting converted into the salicylaldehyde, what we can say is. Yes, Reimer-Tiemann. Very good, very good. Divya, Manisha, very good. It's a Reimer-Tiemann reaction, right? So simply what happens in Reimer-Tiemann reaction, that phenol will react with the chloroform in presence of KOH. Okay. Chloroform will react with the phenol in presence of KOH and it will forms a salicylaldehyde. It will form a salicylaldehyde. Okay. It will form a salicylaldehyde. So this reaction is known as Reimer-Tiemann reaction. And one more thing, that in case of Reimer-Tiemann reaction, there is a one intermediate form. Do you know anyone know about that name of that intermediate? Name of that intermediate, anyone? Which intermediate is get formed into the Reimer-Tiemann reaction? They also ask the question on this. Carbene, yes, very good. Yes, it's a carbene. And which is specific carbene, whether it's a trichloro or dichlorocarbene? Yes, it's a dichlorocarbene. Yes, very good, very good. So, in case of Reimer-Tiemann reaction, the intermediate dichlorocarbene is get formed. And there is also one question in previous year question paper, that in which of the reaction the carbene or a dichlorocarbene is formed as a intermediate. So they have give you the option Reimer-Tiemann or few names of other reaction. Okay, so your answer definitely will be Reimer-Tiemann reaction. Okay. So this is Reimer-Tiemann reaction. Now which reaction this one? Here they are forming salicylic acid. In which reaction salicylic acid is get formed? Kolbe's reaction. See, Kolbe's reaction will be specific name you have to give, because sometimes there is also one more Kolbe where it is a Kolbe electrolysis. It is Kolbe Smith or Kolbe electrolysis. Kolbe Smith or Kolbe electrolysis. You have to know the complete name. Salicylic acid is get formed from the phenol. Yes, Kolbe-Smith. Very good, very good. Yes, it's a Kolbe-Smith reaction. So what happens in Kolbe-Smith reaction? And this is also one of the drug which is a pro drug, and it is converting into the salicylic acid. What is the name of that drug? Which is get converted into the salicylic acid after goes into the body, and it is a pro drug. What is the name of that drug? Aspirin. Very good. Yes, it's a aspirin. Yes, right. 2-acetyloxybenzoic acid. That is aspirin, and that aspirin will undergoes the hydrolysis and it will form a salicylic acid, and that salicylic acid is responsible for the action. Aspirin is a prodrug, right? And in which disease aspirin is used? Aspirin used in which disease? I am also covering some off topic portion, but it will help you in recalling the things, that how fast you are able to recall the things. Anti-inflammatory, but I am asking about the disease. Antiplatelet, yes, as a anticoagulant. After heart surgery, doctor used to prescribe aspirin. Okay. And whether it will be in a low dose or a high dose, antiplatelet activity will be in a high dose or a low dose. Low dose, very good, very good. In low dose, it will act on a COX-1 or a COX-2. In low dose, it will act on a COX-1 or a COX-2. COX-1, yes, COX-1 is correct. Okay. It will act on a COX-1, and in a high dose, it will act on a both COX-1 and COX-2. And because of it act on a COX-2, that's why we are getting the anti-inflammatory effect at a high dose. Okay. Somewhat off target, but it is also important. So you are able to recall the things uh, simultaneously of other subjects. Okay. So here back to the topic. So here the phenol will react with the NOH and it will form a phenoxide, sodium phenoxide. Okay. Or the salt of the, you can say salicylic acid, sodium salt of the salicylic acid. Okay. And this group is known as sodium phenoxide. Okay. So it will form a salt of salicylic acid, and when you react it with the acid, this sodium will get removed. Okay. Here it can also be HCl. If you use HCl, the end product also will be NaCl, also will get separated out. Okay. And it will form a salicylic acid. So this is Kolbe-Smith reaction. So it's a Kolbe-Smith reaction. Which reaction is this one? Which reaction is this one? See, here is a benzaldehyde, and benzaldehyde is forming benzoic acid and benzyl alcohol. And here one more hint I will give you is the 50% NaOH. Now type your answer in chat box. Which reaction is this one? Question from Canizaro was also there in GPAT 2023. Sorry, by mistake, I have just take the name. It's a Canizaro reaction. Okay. Okay, it's a Canizaro. See here, it's a Canizaro reaction, right? So what happens in case of Canizaro reaction? Specifically, it will occurs in a carbonyl compound, specifically in case of aldehydes, when it not contain alpha carbon. Okay, alpha carbon is not present. Okay, there is no alpha carbon. Okay, alpha carbon is not present in the aldehyde like benzaldehyde. It doesn't contain any alpha carbon. Okay, so in that compound, they will gives me a Canizaro reaction. Okay, and after Canizaro reaction, benzaldehyde is also benzaldehyde and also the formaldehyde HCHO can also give the Canizaro reaction. Okay, and that it will converted into the half half mole will convert into the benzoic acid and half will undergo the benzyl it will gives me a benzyl alcohol. Okay, so this is what the Canizaro reaction is. Okay, if I use HCHO, then it will gives me a formic acid and the methanol. Okay, CH3OH and HCOOH, that is formic acid and methanol. If I use formaldehyde, HCHO, here it is benzaldehyde, so it will gives me a benzoic acid and benzyl alcohol. Okay, so this is Canizaro reaction. Now, which reaction is this one? This is very simple. Which reaction is this one? Clemention? No, not Clemenson. It's a Wolff-Kishner reduction. Very good. Yes, it's a Wolff-Kishner reduction. Yes, yes. It's a Wolff-Kishner reduction. Okay. What simply you have to see is this one. This hydrazine, that is NH2NH2, hydrazine, NKOH. Okay, you have to see this hydrazine, KOH, and this ethylene glycol. Whenever you see these three reagent, hydrazine, KOH, and ethylene glycol, it means it's a Wolff-Kishner reduction. And in case of Wolff-Kishner reduction, when the ketone or a aldehyde, it will form a alkane. Yes, very good. It form a alkane. If you see here, it will form a alkane. Okay, it will forms a alkane. Okay, ketone or aldehyde. It can be aromatic here also. If you see, it will form a alkane because this ring is in a substitution. Okay, so see that also. Okay, here it can be a CH3 CO CH3 or any possible like CH3O CH3 CHO. This also can be a starting material. So you have to look in general. Okay, this is general reaction. So you have to see that also. That as a R group, any group, benzene or a you can say methyl, ethyl, any can be possible. Okay, but main you have to see this reagent, hydrazine and all. Okay, and it will form say alkane. So this is Wolff-Kishner reduction. Okay, now we'll see some MCQs. There is one or 4 to 5 more naming reactions are there. Okay, we will see that in next lecture, but we'll see some MCQs as we have more 15-20 minutes to complete. So we'll see some MCQs. Okay, more 4 to 5 naming reactions remaining. that we will cover in the MCQ part also. Some will convert in the MCQ solving in the next slides. Some we will cover, one or two we will cover in the next class. Okay. One or two, just one or two in next class. Okay. So this is the first question. First of all, tell me which reaction this was. This one. Which reaction is this one? First, tell me that. Which reaction is this one? Beckman. Very good. Very good. And what will be the answer for this? Answer क्या होगा इसका? What will be the answer? What will be the answer of this one? You are correct. This is Beckman rearrangement. What will be the answer? D option. D option. Okay. D option. You are sure? Divya, you are sure D option? A option. Sure, you are sure A option. Is it you are sure? D option is correct. Okay. D option is correct. I'm just trying to confuse you. I'm just trying to confuse you. Try to check. I'm trying to check your confidence. Okay. D option is correct. A option is not correct. Why I am telling you this? Because if you see this C6H5 here, okay, I have rounded. This is C6H5 group. So this simply, as I have told you, that you have to just shift the group on the nitrogen and it will be formed a substituted amide. So if you see in D option, this C6H5 here, this one is transferred here on the nitrogen only. See here, this nitrogen. On this nitrogen, this phenyl group is shifted only in this. Nothing you have to change. You need not need to change anything. You not need to change the positioning of this NO2 and Cl. This will be on a same place. Okay, the place of the NO2 and Cl, any group, place of the any group is not going to change. Only your alkyl or aromatic group is going to shift onto the nitrogen. Okay, and one more thing, like sometimes I'm writing, whatever I am writing is visible to everyone, right? Now, sometimes there will be a different group. Here in this case, both are phenyls, right? Here in this case, both are phenyls. But sometimes they give you a different group, like R and R dash. So what happens that when the different group is there, what you have to shift? The trans to this OH. Okay. The group which is trans to this OH, like this R dash group is trans to OH. So this R dash group will transfer on this nitrogen and the product will be accordingly. Okay, so this kind of variation they can ask in your time. Okay, so this, as I have told, as here it is C6H5, so this C6H5 group will transfer onto the nitrogen. Rest of the structure will be same. And as I have told in Beckman, it is formed a amide, substituted amide, right? So this amide group here, nothing is going to change. This NO2 will be say on a same place and this chlorine will also be on a same place. This methyl, phenyl is get shifted onto the nitrogen. Okay, clear to everyone. And if it is different group, then you have to see the trans 2OH. This R dash group here in this case, this R dash group is trans 2OH. Okay, so this R dash group will transferred onto the nitrogen and product like this will be formed. Okay, so this product will be formed. Everyone clear with this? Everyone? Any question in this question? If you are not able to get, this is from the GPAT 2022. Okay, this is from the GPAT 2022. If you are not able to get, you can tell. Okay. So this is the next reaction. This is from the GPAT 2023. Okay, second shift. As it was in the two shift, paper was in two shift. This is from the second shift. What will be the answer? Replacement of diazonium group by the halogen in presence of copper powder. This is one more renaming reaction. Yes, yes, it is Getterman. Don't see the chosen option. Okay, it is of the someone's paper. So they have choose the option 1. So they are wrong. Okay, this is Getterman reaction, because in Getterman reaction we are using Cu powder. Both reactions are same, but the reagent is different. In both reaction, your diazonium salt, like for example, I used benzene diazonium chloride. So this benzene diazonium chloride will get converted into the chlorobenzene, and the nitrogen is get removed. Now if I use Cu powder, then it will be Getterman reaction. And if I use here CuCl, okay, instead of Cu powder, if I use CuCl, then it will be known as Sandmeyer. Yes, Sandmeyer reaction. Yes, very good. Sandmeyer reaction. Okay. And the Hoffman reaction, as we have discussed. Okay. Or Hoffman bromamide degradation or Hoffman rearrangement. Okay. So try to see the every option, that why this option is not correct and why this option is correct. So you will get more idea. Okay. Why not Sandmeyer, but why Getterman reaction? See this guy, whose paper is this? He get confused between this Getterman and Sandmeyer. So here by mistake he click the Sandmeyer. So this kind of things you have to observe. Here it is powder is written, not the cuprous chloride, right? Cuprous, because it's a +1 valency of this copper. So that's why it's a cuprous chloride. If cuprous chloride is used, then it's Sandmeyer. But here we are using copper powder. So that reaction is known as Getterman. Okay. So this is correct answer. Now, this is the blank is the example of aromatic nucleophilic substitution reaction. What will be the answer? Aromatic nucleophilic substitution. Yesterday, I have talked about the electrophilic substitution reaction. We will see it in a next lecture, this electrophilic substitution reaction, and some MCQ based on that. Friedel-Crafts reaction. It is not electrophilic. Again, I am repeating, they are asking nucleophilic substitution. See, this kind of mistakes, student frequently make this kind of mistakes. They are asking not electrophilic, they are asking nucleophilic. Read question properly. They are asking nucleophilic aromatic substitution. This fourth option will be correct if I am asking about electrophilic. Not Getterman beta Ankit. Aniket, it's just a dash. It's not, I haven't ticked this MC option. I haven't ticked this option. It's just a dash. From the previous slide, it was just a dash. Second one is also not a correct option. This one is electrophilic substitution, okay? And the question is about the nucleophilic aromatic. Aromatic. Answer is chichibabin. Yes, chichibabin is correct answer. Okay. Chichibabin is correct answer. Chichibabin happens in which heterocyclic ring? In which heterocycle? Pyridine. Very good, beta. Pyridine. Very good. Very good, Karthikeyan. Very good. It happens in the pyridine. When pyridine react with the NaNH2, it will gives me a 2-aminopyridine. Okay. 2-aminopyridine. Yes. So this is chichibabin reaction. Okay. So the correct answer is chichibabin. Because here this NH2 act as a nucleophile and attacked on this second carbon of the pyridine. Again, I am repeating, nucleophile, not electrophile. Yes, aromatic rings in general they gives the electrophilic substitution reaction, but there are some reactions, as chemistry is a subject of you can say some differences. So there will be some difference from the existing theories and reactions. So here also a difference, that is chichibabin is a nucleophilic substitution reaction. Okay, and take place in the pyridine in presence of sodamide, and it will gives me 2-aminopyridine. Okay, so here correct answer is chichibabin. If it was the electrophilic substitution, then the correct answer will be Fiedel-Crafts reaction. Okay, then it will be Fiedel-Crafts reaction. And what about Getterman-Koch reaction? Anyone? Which product is formed in Getterman? We'll see this reaction in next class also. But if anyone knows, which product will be formed in Getterman? Yes, very good, beta, Divya and Manisha. Benzaldehyde, yes, benzaldehyde, yes, yes. Now this question, phenol react with the chloroform in presence of aqueous sodium hydroxide to give chief product. First tell me which reaction is this one and what will be the name of the final product. They are asking IUPSC name. Reimer diamond, yes, and what will be the correct answer? What will be the correct answer? 2-hydroxybenzaldehyde or a 3-hydroxybenzaldehyde? Yes, very good, very good. 2-hydroxybenzaldehyde, yes. See that also, okay? Don't confuse between the 2 and 3-hydroxybenzaldehyde. Because the final product is 2-hydroxy, that is salicylaldehyde. So here this is the first position and this is second one. Okay, so that's why it's a 2-hydroxy benzaldehyde. Okay. This is from the GPAT 2023. Just previous year. Okay, second shift question paper. Now here the question comes. Insertion of oxygen in a carbonyl compound to form an ester is known as. Yes, Bayer-Villiger. As I have told you in starting also. Okay. And I think I'm not able to find that MCQ, but in previous year question paper, there are also questions from the Beckman rearrangement itself, that in which reaction, which of the following The rearrangement of group will take place on the nitrogen. Rearrangement of the group will take place on the nitrogen. Okay, on the nitrogen. So that will be Beckman, then the Smith rearrangement, then the Curtius, and also the Hofmann bromamide, where the shifting of the group or rearrangement of the alkyl group is taking place on the nitrogen. Here they are asking about the oxygen. Okay, so that will be a Bayer-Williger oxidation or a reaction. Specifically, why they are telling it as a oxidation, because your ketone is getting converted into ester. So that ester contain extra oxygen, right? Ketone will contain one oxygen and the ester will contain extra one more oxygen, C double O group, right? So that's why they have written Bayer-Williger oxidation. Okay, everyone clear with this? This is all from the GPAT 2022. The previous question was from the GPAT 2022. Now here the one more question comes. Controlled alkylation of a ketone via enamine intermediate is named as Mannich reaction, Robinson annulation, Stork reaction, and Bamford-Stevens reaction. Yes, very good. What was the starting material in case of Stork reaction? And which reagent we have used? You also need to know that. Ketone, but which ketone? In general, as I have told, cyclohexanone. Very good, beta. Yes. And also the reagent we have used. Which reagent? Which reagent? It is forming imine. Because of which reagent? Pyrrolidine, right? Pyrrolidine, yes. So the correct answer is Stork reaction. Okay. And what about Mannich reaction? This Mannich reaction is also used in the synthesis of one drug, if you know. Can you name that drug? Can you name that drug? Anyone? Triprolidine. Very good, beta Karthikeyan. Very good, very good. This Mannich reaction is also used in the synthesis of triprolidine. Okay, in Mannich reaction, simply your uh, acetophenone, the formaldehyde, and your ammonia will get react and it will form an intermediate. That is a Mannich reaction. Okay, starting material is, I think, acetophenone, formaldehyde, and the ammonia, or we can say the aldehyde, which doesn't contain any alpha carbon. So that is a Mannich reaction. Okay, and triprolidine is the drug. In the synthesis of triprolidine, Mannich reaction is used. Okay, and we have seen the Robinson annulation and Bamford-Stevens also. Okay, clear everyone? Now, what about this? Which reaction is this one? They have asked you the reagent also, but I also want to know the name. I also want to know the name of this reaction. Yes, you are correct that C option is correct. Yes, it's a Wolff-Kishner rearrangement. But if you see, this question was controversial. In this was also from the GPAT 2022. Why this question was somewhat controversial? Because they haven't mentioned acid or base. Okay, they haven't mentioned whether it's in an acidic condition or a basic condition. But as this same reaction was given in a one reference book, I think it's a Bal and Bal. I think I'm not able to correctly recall, but I think I'm sure about. I think it's a Bal and Bal. So the same reaction is given and they have given this option, or you can say they have given the Wolff-Kishner. In the example of Wolff-Kishner reduction, they have given this answer. Okay. And that's why answer they have considered this one. Okay. Otherwise, this also can be possible answer. That's why, yes, Manisha, I am asking about that. This question was controversial. That is what I am telling, Manisha. Okay. This question was controversial. That why option not option one. Both can be right. But as in the reference book, they have given the NHNH2 and NaOH. And that's why they have considered the answer NHNH2 and NaOH. Okay. Not this ZnHg and HCl. Otherwise, both answer is right. But they haven't considered because in reference book NHNH2 and NaOH was given. Okay. This is also from the GPAT 2022. Now, what will be the answer of this question? If you guys able to give the answer of this question, it means that your organic chemistry is also on a path. That you have a very good understanding of organic chemistry. This is also from this question is from the GPAT 2022. Sorry, 2023. Second shift, 2023. What will be the answer? Second. Okay. Think again, beta. Think again. Second answer is not correct. See again, see. No. Yes. Second is not correct, but first option is correct. Very good. Very good. Yes. Second option is not correct, but first option is correct. Why? Because see here, first addition reaction is taking place and it is a electrophilic addition. Alkene give which reaction? Alkenes gives which reaction? Alkenes. Alkene, not alkane. Alkene. Alkene gives which reaction? Addition reaction. Yes. Which addition but? Whether electrophilic or a nucleophilic addition? Electrophilic or nucleophilic? Electrophilic addition or a nucleophilic? Electrophilic addition. Okay. Alkene gives electrophilic addition. Nucleophilic addition will give by the aldehyde and ketones. They will give nucleophilic addition. Alkene gives electrophilic addition. The first one is a electrophilic addition. Okay, ED I have written electrophilic addition. Okay, then so that's why these two bromines are here. So A is a Br2. Then this one, if you see, it's a KOH. Okay, and as it is KOH, and specifically they have removed here, they have removed HBr. It means it is going to be a elimination or a substitution reaction. It is going to elimination or a substitution. Elimination, yes. Haripriya, yes. Karthikeyan, yes. It's a elimination reaction. Okay, and that's why they have removed HBr from here. And that's why this double bond is formed here. Okay, and again it undergoes converted into the alkyne. That is propine. This is propine, right? Okay, and when alkene react with the alkene, I am saying, okay, when alkene react with the sodamide, it will gives me a alkyne. And this here is this alkyne is propine as 3 carbons are present. Okay, and that's why the option A is correct. Okay, this is from the GPAT 2023. Everyone clear with this question? Okay. And the last question we will take. Alkyl group in a Grignard reagent serve as. What will be the answer? Second, no beta Divya. Manisha, you are right. Yes, carb anion. Right? Carb anion. Because what happens in Grignard? What happens in Grignard? For example, if you have this compound CH3MgX, this is Grignard reagent, right? RMgX. Yes, yes, very good, Manisha. It's RMgX. Metal get positive charge. Yes, very good. So this Grignard will convert into the carbanion. This means alkyl group will convert into the carbanion, and this MgX group will removed as a positive charge compound. Okay. And then this alkyne, carb anion will attack on your particular group. If you are reacting it with the ketone, then it will simultaneously form the alcohol. Okay. That we will see in next lecture. But this is what about today's class. I think we can see one more MCQ. Okay. Last MCQ. Remaining 2-3 MCQs we will see in next lecture, and then we will move towards the heterocyclic compounds. Okay. See, read this question and give your answer. Which of the following factor make carbonyl group in acyl compound to susceptible to nucleophilic attack? Read the all options properly and answer in chat box. This is the last MCQ for today. Okay. Uh, Next few 2 to 3 MCQs and 2 to 3 naming reaction we will see in next lecture, and then we will shift to the heterocyclic compounds. And also some portion of the, as someone was telling about the electrophilic substitution reaction in the aromatic compounds. So some MCQs on the order of that electrophilic substitution reaction that we will also see in next lecture, and some part of the heterocyclic compound, and some heterocyclic naming reaction which are used to synthesize the heterocycles. What will be the answer of this question? Think and answer. Vivek Karanjar. 2. Okay. 2. 2. Yes. Why 2? Can you tell me the reason why second option is correct? You must know the reason behind it, so it will be more good for you. Why second option is correct? A very simple and a very basic reason is behind that. Why it is written that the tendency of oxygen to acquire electron? Why oxygen will attract the electron? Because of which phenomena? It's because of the electronegativity, right? Yes. And as oxygen is electronegative, so what will happen? This oxygen will pull the electron of this bond towards itself, and that's why it's get partial negative charge, and here it's partial positive charge. So they are asking this thing. See, they are just playing with the words and they are trying to confuse you. Okay, this is very basic concept in carbonyl compounds, that oxygen will acquire partial negative, and carbonyl will acquire partial positive because of the tendency of oxygen to acquire the electrons, right? It will attract the electron because of the electronegativity. And this is also from the question from the GPAT 2023. So this is for the today. If you have any question, you can ask. This is for today. We have solved some MCQs on the naming reaction. Also, we have started with the order of the mesomeric effect group. One MCQ on that, and then the some very important naming reaction and their MCQs we have covered. And if you have observed, these all questions are from the recent year papers itself, and you can see that how important these basic concepts and this naming reactions are. If you have calculate how many number of MCQs we have solved in these 2 days, and you can correlate that why I have told that 10 to 15 MCQs you are able to find from this entire portions. Any question, anyone? Any question from today's session? Otherwise, we will complete. Any question? Any doubt, any question you can ask. Otherwise, we can end up the session. Okay, okay, beta. If you have any question, you can ask in next lecture also. Okay. If you get question after the session. Okay. Thank you to join and thank you to listen and hope to see you all in next lecture. We will start with the some MCQs and some naming reaction. Remaining two, three naming reactions are remaining, and some MCQs of some question on that. And then we will move towards the heterocyclic compound, their nomenclature and the naming reactions which are used to synthesize the heterocycles. Okay. Thank you. Thank you. Have a great day. Have a great day.
Thank you so much, sir.
Thank you, ma'am.